Hi, I'm Tyler Stokes, and today I'm going to be teaching differential equations. Dictionary.com defines differential equations as equations containing differentials or derivatives of blah 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 blah. That's the problem with having language majors explain math concepts. Pretty much, differential equations, or DiffEqs for short, is comparing rates of change between two things. Still don't get it? It's cool. Maybe this example will help. In 1995, the gray wolf species was reintroduced into Yellowstone National Park. This produced a change in the elk population within the park. What happened, one might ask? Well, the wolves hunted the elk for food, causing the elk population to drop. Due to the large amount of food, the wolves grew in numbers, allowing them to consume more. As a result, the number of elk decreased to a critical level. To survive, they played a big game of hide and seek. Many wolves were unable to eat and eventually starved, causing the number of gray wolves to decrease. Because of this, the elk were able to produce more offspring and the population increased again. Oh wait, more elk equals more food, which therefore equals more big bad wolves. This is called the Lotka-Volterra model, or the predator-prey model, and is shown using DiffEqs. Ugh, that looks kinda ugly, don't it? Well, let's break it down and talk about what everything means. D means the change in. E is the population of elk. A is the rate at which elk are born. C is the number of elk eaten. W is the population of gray wolves. T is time. R is the rate wolves can be raised per consumption of elk. And N is the natural death of. Now that we know what everything is, let's start piecing it together. The first equation reads, the change in elk over the change in time is equal to the number of elk that can be born minus the amount of elk that are eaten by a number of wolves at that population of elk. So simply put, it shows how quick the elk are born to how quick they die. The second one reads, the change in wolves over the change in time is equal to the number of wolves that can be born per amount of food available minus the rate at which the wolves die at that population of wolves. If elk are born quicker than they are being eaten, they increase in population. As a result, the number of wolves that can be born increases because of more available food. The elk are now eaten quicker because there are more wolves and the population decreases. Because of this, the wolves don't have enough food and starve without having pups. Although population growth of elk and wolves is interesting, DiffEqs can be used elsewhere. To determine radioactive decay? Sure. Why not? Movement of objects? Absolutely. Maybe even come up with a solution to global hunger. This has been DiffEqs in a wolf's tale.